Welcome all in this video lecture series for design and analysis of algorithms. In this video, we are going to look at the activity selection from the viewpoint of backtracking. We will try to generate the possible solutions, and then we will try to see that from the solutions can we find out that other than backtracking, can we use any other method to find out an efficient solution as compared to the backtracking? That's what we do in this video lectures. So let's try to look at the first, what do you mean by activity selections. Now in the activity selections, you will be given a list of activities with a start and finish time. Obviously the finish time is equal to or the greater than the start times. Now your task is that you have a single processor to finish this activity. So what is your goal? That you have to schedule maximum number of activities. That is your goal of this particular problem. And you have a single processor, so of course at a time one activity go, then the other activity, then so on. So that's why you have to make sure the activity is compatible with each other. So consider that I want to schedule a lecture in a class. So now consider that I will give them a slots, like other faculty also give them a slots, and then using this algorithm activity selections, they will try to schedule a number of more lectures in a day. In that case, they will check out the compatibility so that it will make sure in the same time know that two faculties teaching in the same class. That is what it will do. Now other advantage of this thing is in conferences. Like in the research conferences, the paper is supposed to be presented. In the presentation schedules, if the schedules is fixed with start and finish time, what is the starting and finish, then it will try to utilize a maximum numbers. It will ask the speakers what is the time that you're supposed to take, and from that time they will try to see that okay, how many more speakers in a day they can try to avoid. If they have only one room to do this thing, then that is a more useful process. So that is what this activity selections, to maximize the number of activities to utilize on a single processor. So here we will try the activity selection problems, we will use the backtracking, and we will see from the answers, will it be solvable by any other technique? That is the question. So of course, why to use the backtracking? So that's try to give this particular slide to the readers that, well, backtracking, of course we have algorithms for this activity selection. Using the greedy you can solve, but well, the backtracking will give you all the solution of a given problem. So now consider this particular video as a thing that okay, if tomorrow you will go to some new problem to solve, now you don't know whether greedy or divide and conquer or dynamic programming which you are going to use. So now in that case, what you do, you will try to use the backtracking, because backtracking will give you the answer, not the answer, all possible answers. So from that backtracking, you will try to generate a state space tree. Well, if you want to go in the detail of what is state space tree, you will refer my other videos that is specifically on the state space tree. So here in this case, you will generate a state space tree from a given problem, and that from that thing you will try to identify what are the solutions, if there are more than ones, okay, and from the solutions you will try to find the patterns, and that patterns you will try to match with the greedy or the divide and conquer or the dynamic programming, and you will see that if that is possible, yeah, then you can use it. Yeah. So here, first thing, the problem with the only backtracking is that, let's say for a same this approach, we can use the backtracking, we can use the greedy. Then what is the disadvantage of backtracking? Well, we said that first we apply the backtracking, then we get the answer, then we go with the greedy. Now here in this case, the problem with the backtracking is that the time, that is a problem. Well, you can get all the solutions, but the time, that is much more. So that's why in the backtracking, if we want to use only the backtracking method, then we have to deal with the time and resources that is much more. The other advantage of using the backtracking, that you can see that in some problem that where other technique fails or not efficient to give you the exact answer, backtracking is possible to give you the answer, but the problem is time. That is the problem. It will take much more time compared to other algorithm technique that is give you the kind of answer in efficient way. So this lecture try to showcase the bridge between the greedy and the backtracking, and how can we use this problem statement to first start with the backtracking and you will end up in a greedy methods. That is what the unique advantage of this particular video lectures. So of course what we do in our research, when we got certain problems, a generalized problem, we will try to see the how many patterns is possible, and from that patterns what we do, we will try to find the more possible solutions, and we will try to check whether can we have a some pattern that becomes unique between all the problems. So the backtracking will give you all the possible solutions similar to the patterns in the research. So that's why this lecture series is designed specifically to give the or remove the gap between these two techniques. And yes, we will try to not only use the simple method of a backtracking, we try to use the intelligent methods. So that's we will take to look at the examples. So this is a state space tree. For your understanding, I have already given the same problem statement here. Now we start with the first empty solution. This means the empty solutions. Now empty solution, it means that for any problem the solution exists. That's what the algorithm tells you. Okay, time, space, that is other thing, fine, but for every problem there is a solution that is possible. So we start with the empty set. Now it's a depth first search. So first we will explore the one, because there are 4 activity that is possible. So that's why this particular node is a 4 children's. Now if we start with first activity, well, we set the 1 and 4. Now the moment we set the first activity, can we take the second activity? No, because the start time is 3, finish time is 4. Can I take the third activity? Well, no, because it will finish at 4, and how can we start at 0? Well, the finish time of this activity is equal to or the less than of the start time of the next activity. That is the requirements, because it's a single processor. At a time one activity can be handled. It's like at a time one faculty is going to teach you in a class. In similar way, at a time one activity is going to run in a process. So 2 is not compatible with 1, 3 is not compatible with 1, yeah, 4 is compatible with 1. Now the moment you set the 4, 5 and 7, well, 7 is the highest finish time, so it means the other activity we cannot set it. So again we backtrack here. 1, we don't have any other activity. We will come here, we will try to explore the second activity as a fresh start. The moment you set the second activity, then 2 and 4, so here 2 you will set it. So now the moment you set the 2 here, that is 3 and 5, then you will take the third activity and then the 4, because the 1 is not compatible with 2 and 3 is also not compatible with 2. So that's why you have to resort to the 4 here, 4, and then again you will come back here. 2, there is no other activity, you can take it, you will come back here. Now you will come back to the 3. The moment you start with the third 3 as a first activity, then the 3 will be here. You will take 0 to 6. The moment you take 0 to 6, can I take 1? Well, 1 to 4, no. 3 to 5, no. 5 to 7, no. Means there is no particular path. So now you can see this cross will be the intelligent methods, because if I know that there is no way in going a depth of that particular tree, because I don't get a solution there, that's why I don't need to go in the detail of that particular depth of a graph. So that's why we will try to return from that particular path without going in the detail. So that is makes this method as an intelligent. Again 3, I will come back. then 4, 4 I will come here, then 4 I will check it out, 4. If I take the activity 4, 5 and 7, then is there any other activity that I will take after 7's? Do I have any other activity to take after this finish time? Well, no, so I'll better try to stop here. Okay, because we assume here that after 7 we will try to look at activity, we will not take the activity before 5. Yes, if you want, what you can do is that you can also put it 1 here in place of a cross. So in that case you have to assume that you can take any activity that is less than this thing start time and greater than this 4 times. So the 7 is possible in that way. So 1 and 2, in that case you will take a 2 particular here, 1 and 2 both will, you will get it here. That is possible. Okay, but ultimately our goal is to identify the pattern, that's we can able to get it. So now in this particular approach, 1 and 4 and okay 2 sorry and 4, that's you can take it. Now if you can look at this 1 and 4 and 2 and 4, so 1 and 4, if I take 1 and 4, this 1 and 4, now what thing that is common? Well, that is finish time, 4 and 7. Well, that's a good thing, I can take that thing. And if you take the 2 and 4, well, let's take 2 and 4, 2 and 4. Again the finish time and the start time, that both will come in the picture. Here finish time it is in sorting, so that's why you have two possibilities. You have a sorting time of a start time and you have a sorting time of a finish time. So from that, if you take more examples in that way, then you will came to know that you have to use the finish time in a sorting order. So the moment you know there is a pattern possible of a sorting time of finish, so that's why it lead to you to work on a greedy method, because in the greedy you have to follow a greedy criteria in a one way. So now here, if we have a greedy criteria that we got from a backtracking, that is a finish orders, in that way if we continue, so that will give us a maximum activities. So that's what this particular video tells you, that first apply backtracking, get a state space tree, get the answers, all solutions, look at the solution, try to find out if there is any pattern that is going on. Then from the pattern you will get to know that okay, this will lead to this particular techniques, and then you can try to devise using the techniques criteria a problem solving. So for more details on using what given by activity selections, or what given by backtracking, what given by state space tree, or any other problems, you can refer the videos other, as well as the books as per the syllabus, the NPTEL, MIT videos, any other relevant material on this problem sentence, and try to be linked. So this video is kind of a linkage between the two techniques that is there. Thank you everyone for watching this video. I hope that this video will try to motivate you to find out or relations between the two techniques that is possible, and try to devise the solutions of upcoming problems that will get.